Okay, so today we're going to look at log graphs. And so a log graph function with a base of A, so is drawn exactly the same way with any other bases. So what we're saying here, so you can see down along here, we've got this same shape, yeah? So it didn't matter, that's log 2 of x. When you've got log e of x, it's still that same shape. So let's have a look at what some of those things of that basic graph here. So if you look at it, the first point here is that they're saying that that the graphs all cross at 1, 0. So if you've got log 2 of x or log e of x or log 10 of x, they're all the same. See how they're all crossing the x-axis at 1, 0. So that would be like your basic. So when we can use that to do a little bit of our moving around when we have transformations. Now, it has a vertical asymptote at the y-axis. So if you say the y-axis is a vertical asymptote, the actual equation of that asymptote is actually x equals 0, yeah? So this is the asymptote. So what do we mean by the asymptote? We can see, sorry, I'll just rub that bit out. So you can see as the graph, so as the x values approach 0, see how it gets closer and closer to that axis, but it never touches it. So when you see that, so we can see when we're asked about the domain, what's the domain, we can see that you're always in the positive area of the x values. So that's why the domain of a basic log graph is the real field, positive real field. And so you might want to write on the side there, you can write that as notation as not quite 0, curly brackets like that. Okay, so that's another way to write it. That might help you out. So if we look at the range, remember that the range is all the y values. So if you look along, where this graph is covering, it's covering all the y values, isn't it? So it's the real field. So we'll just say the real field R. Okay, so they are, when you have the basic one, so that's a positive. So we've got, like, say y equals log 2x, the function's a positive function. We can see that it increases. So as x gets bigger, the line's going up like that, okay? And it can be seen that the smaller value, if you have a smaller value of a, so if that base is smaller, so probably best to have a look here at the log 2 and the log 10. So when it's the A or the base is smaller, you see that this graph is steeper. Yeah, so and you see the log 10 is a bit more flat, a bit flatter, not as steep, doesn't go up as quick. All right, so have a look. So what we're going to do is we're going to do some log graphs. So we know now, so what you've got to think about is you now can quickly draw, if you're going to draw your basic one, so always remember like your basic one. So we know it asymptoted on the x equals 0. So your basic one looked like that, yeah? And we had 1, 0. There you go. I'm just doing a rough thing. So let's have a look at if we're asked to sketch this one. So it's got a base of 2, but we've got a few things that have moved. Now, see how when we've got this plus 1 in here. So when you have a number on the x part, that translate or moves the graph either left or right. So if we've got a plus 1, it moves it to the left, doesn't it? Remember that with our transformations? So when we originally had our asymptote on x equals 0, I'm going to move that asymptote to the left by 1. So here is now I've put this asymptote as x equals 1. All right, now we've probably got, so we know if we think about, all right, it's moved along and we're going to sketch it that shape. So the -1 moves it up and down, but we probably won't be able to see that as much in a sketch. We'll probably look at looking at the intercepts. So if you think if we've moved that asymptote over, we're probably going to get something, you know, I'm just roughly something like that. So I'm now probably going to get an X and Y intercept, aren't I? Both. Yes? Can you see that? So that's what we're going to think about. We know that it's going to look like that. So let's go get our, sorry, I'm going to rub that out. Let's go get our X and Y intercepts. All right, so let's do, which one do you want to do? Do the Y-intercept first. So the Y-intercept, what's the fact we know about the Y-intercept? What do you know what happens at the Y-intercept? X equals 0. So you know that for every graph, yeah? So let's do that. So what we're going to do is we will have log y equals log 2, and it's pretty 0 plus 1 minus 1. Okay? So really I've got log 2, 1 minus 1. Alright, so what you're going to do, if you don't have your calculators, obviously if you've got your calculators you just sketch it, trace it, get the intercepts nicely, but we don't. So if we think about this, if we've got to know how to work out what log 2 of 1, so remember back to our log rules, if I was trying to work this out, say I'm just going to call it h, like I want to know what it equals, yeah? So I've called it h. Do you remember when we said we could say 2 of h equals the 1, yeah? And then I try to match up the bases, so remember 1 can be written like that, can't it? 2 to the power of 0. Yeah, so h equals 0. So I know that this part is worth 0. So really, if I go back to working out my y-intercept, I've got y equals 0 minus 1. So the y-intercept is at -1. Yeah? So we'll pop that in. So I might put it at, so the y-intercept down at here, I'll say that's -1. So I'm going to say 0, -1. Okay, so let's go and find the x-intercept now. So what's the x-intercept is when? What do we know about it? Y equals 0. So I'll write out the formula with y equals 0 first. Okay, and then I'm going to go about solving it. So if I moved this -1 over the equal sign, I would end up with 1 equals log 2 x plus 1, yeah? And remember, if you can, like what we did here with the flicking around, so I could say 2 to the power of 1 equals x plus 1, can't I? Remember, that's how you can flick it around, yes? So sometimes when you've been doing it, just to show you, you've probably seen it, it's just had this part written first, yeah, equals 1. Yeah, and remember that rule where we can change it. We can say the base to the power of the answer equals what was next to the log. All right, that's one of the log rules, okay? So then 2 to the power of 1 is obviously 2, yeah, x plus 1. So then you bring the 1 over, it'd be 2 minus 1. So what do we get? The x-intercept is at 1. So I'm just going to call that dot 1. So I've got 1, 0. So, and we remember it's still the same sort of shape and it asymptotes over at this x is -1. So I'll just draw it like that. Oh my God, mine's pretty bad. I'll fix that up. You've got to be a bit, I'm pretty poor at drawing the graphs, but like that, just, yeah? And then we'll pop the lines on it, or the equation. X plus 1 minus 1. Right, now also, let's have a think about it. I want you to think about the domain and the ranges. We should do that for every graph because they're going to ask you probably all the time. All right, so the domain is what values x can be. So what's the smallest, or what's the closest it can get to the smallest number there? Yeah, so it never touches -1, does it? So that's why I'm drawing a curved bracket. You remember that? What happens if you do include it? What type of bracket is it? Square bracket, good. So, and then it goes on to any number bigger than -1. So I'm going to use the infinity symbol. and with the infinity symbol, it has to be a curl bracket. Yeah? Okay, now the range is what values that the y takes on. So look up and down the y-axis, and what is it taking on? It could be anything, couldn't it? Because it'd go all the way down, and it eventually can keep going up and up and up and up and up. So what do I call that? Yeah, we'll just call that R, the real field. Beautiful. Okay, so with this one, we've got it here. It says graph the function 2 minus 3 log 2 1 minus x. Okay, so just to show you, I've written it out like we would normally do, because I put this plus 2 over here. So instead of being at the front, I put it at the end because I'm used to seeing it like that, and I know that's the up and down transformation. Yeah, so what I've done there, so here, first of all, I'm going to look at where my asymptote is, because remember, we're just going to remember a basic one starts off like that, yeah? Okay, so I'm going to look at the asymptote. So the asymptote is going to be, a basic one's on x equals 0. So let's see where it's going to go, left or right. So when we're doing that, we're actually looking at this part of the equation. Now, it's not written with like x and then the number, but can you see if I factorized this just this 1 minus x, if I take negative 1 out, can you see how it becomes x minus 1? Yes? So if you just looked at that x minus 1, the minus 1 means we move the graph, doesn't it? This would mean move right 1. Is that true? Yeah? So we're going to move that asymptote. Can you see that's why I've put this asymptote here? And then I drew, just to show you, well, there's my basic graph with the new asymptote. All right? So this one would actually just be, that purple line would be y equals, I'm just going to say 3 log 2 1 minus x, okay? So that's all that bit. You know, it's the moving of that. Now, if we have a look at what all the other bits though, okay? So if you look in here, we've at the start of this one, we actually have here, that's a negative. So we're saying really that the whole function is negative. And when the whole function is negative, you reflect it in the x-axis. So remember, I often say sometimes using quadratics helps to remember, because you guys, it's easy to remember a positive and negative quadratic. So remember a positive x squared, remember a negative x squared. So see how it reflected in the x-axis? Yeah, so if the x-axis was a mirror, it would look the opposite. So what I'm going to do, so say this this purple line was the basic one. See how I pretended if this x-axis was a mirror, see how the green one comes about? Yes? So I've reflected that there. So that's the first reflection. Okay, so when the whole function, when you're making the whole thing negative at the front, you reflect in the x-axis. But if you look down in our, we've actually got in here, in there, actually the x is negative as well. So when you make the x negative in the formula, that reflects it in the y-axis. So I'm going to pretend that this thing is a mirror. And so I'm going to, I'm reflecting the green one. And can you see, like, but my y-axis is not y anymore, because remember I moved it over. So I'm going to reflect it on the asymptote. Yeah? Does that make sense? So here, this red line, a bit dodgy, but it's reflecting the green one. I think the green one I drew a bit harsh, but yeah. Okay? So that's how I've got it. So now I know it looks something like that. We should go and check. So I at least know it's asymptoting the on this side, on the left-hand side. And I know, so, but we probably need to go and find out what the X and Y intercepts are so that we can draw it properly and you can exactly see where it's crossing. So let's go do that. now. Okay, so which one do we want to do first? I'll do the y-intercept. So y-intercept, what do we know when it's the y-intercept? X equals 0. It helps you do that. This is what I do, and I've been doing questions for years. You know what I mean? So I try to do it because sometimes you're not going to remember everything. So if I quote myself, and I'll work it out. So, all right, I'm going to write the equation. I'm just using the way I wrote it out. It doesn't really matter either way. So plus 2. So we are now going to change x to 0. So I end up with -3 times log 2, 1 plus 2. And this is what y equals. Yeah? So then we've got to think about working this out. So like before, I need to know what log 2 of 1 is. So if you want to think about it, I'll just do like what I did before. I said log 2 of 1. I'm making up a letter. I'm going to do what I did before. I used h, yeah? I don't want to use x so it doesn't confuse you, yeah? So I just want to know what that equals. So I'll call it h. So remember, 2 to the power of h equals 1. If I change that to the base, isn't 1 the same as 2 to the 0? Yeah? So h equals 0. So log 2 of 1 is 0, isn't it? So now I know this bit in here, this is equal to 0. So my y-intercept, I go back, I've got y equals -3 times 0 plus 2. So what's the y-intercept? Is 2. So can you see up over here, because I'd prepared it earlier, 0, 2, yeah? So that's where it's crossing there. And now we're going to do just our x-axis, our x-intercept. I'll just draw it in black so you can tell the difference. So x-intercept, what's the fact? I know that y equals 0. So I'll write that in first. I'll keep it in the same way this time. Okay, so we're going to solve that. I'll move this to, I'm going to move the 2 over first. So I'll move that over. And that would become, that's actually -2. It's adding on that side. So I've got -2 equals log 2, 1 minus x. Okay, now, can you see I'm going to move this -3, which is timesing. So I move it over, I'm going to divide. So I'll have -2 divided by -3 equals log 2, 1 minus x. So that becomes 2 over 3 positive and 1 minus x. So now I'm going to do the log trick, yeah, where I can say 2 to the power of 2/3, yes, equals 1 minus x. And if I kept rearranging, I want x to be positive. So if I brought that x over here, it would be that. And then if I want to get x by itself, it'll be x equals, it'll be x equals 1 minus 1, oh God. 1 minus 2 to the power of 2/3. Okay, you can't work that out because you don't have your calculator. I'm just pretending we don't have our calculator. If you have your calculator, just go trace it. This is actually the exact answer for the intercept. When you get that decimal answer for your thing, that's not an exact answer. So really, I want to put the exact answer up there. So all I'll do is I just write, so this point here is actually 1 minus 2. I just leave it like that. I can't work that out without a calculator. So I'll leave it like that and then comma 0. And it ends up being, if you do it on your calculator, you'll see that's roughly -0.5. Okay? So just leave that like that and there's your graph. All right, one last thing we need to do is check out what our domain is. So the red one is the graph that we're looking at, yeah? So what is the X values that it's taking on? What's the smallest number it can be? Negative infinity, good. So you can actually just put infinity first, yeah, because you know that's all the numbers before. And what's the largest number it can get up to for the X? 1, good. So we'll put 1 in a curly bracket. And what's our range? So what values of Y is it? It's covering the whole thing, isn't it? So real field.